In this presentation, I would like to walk you through the steps necessary to build a transactional model, sometimes called a cross-legged autoregressive model, in Onyx software. And I'm just showing you this so that you can see that I'm using version 1.0-1026. So I've already loaded the data that we'll use in this demonstration, and so now I'm going to create an empty model. And what I'm going to do, just for no particular reason, is I'm going to choose this first set of variables. L stands for language, G2 would be grade 2. And so I can drop in successive grades of scores. And this is sometimes referred to as, well, when we connect them here, we can auto-regress each variable on its prior time point. And that is sometimes referred to as a stability model. And so here we see 0.82, 0.87, and then 1.04. And these are in unstandardized units. One way to standardize them is to right-click and then do show standardized paths. But instead, what I'm going to do is I'm actually going to apply a z transformation to these variables. And that way the paths are all standardized, and you can see that the autoregressive path goes up. Now, one thing that we can do is we can actually test to see, is that a significant difference? And so what we will do is we'll add some constraints. And the way that you constrain paths in Onyx is you actually give them the same name. So I'm right-clicking on the path, and let's just call this A. And then let's call this path A. And let's call this path A. And you'll notice that all the paths now read the same number. Now the question is that constraint justified? And so one thing that we can do is we can essentially do a statistical test, and that statistical test will tell us in essence whether those constraints are justified or not. And so what we do, and is we're actually going to take a step back so I can show this to you, is we're going to label these separately, A1, A2, A3. And we're going to look at the output. And the output that we want to see is this show estimate summary. And in Onyx, you want to make sure that it says this estimate is reliably converged before you do any interpretation. And now we're going to track a couple numbers here. And so I have this Excel table, and essentially we're going to get the chi-square and the degrees of freedom. Now, no constraints, the chi-square, and this is the chi-square that we want, the one that's just labeled chi-square, is 80.122. And the degrees of freedom, you want to look on this restricted degrees of freedom line. That's 3. And then these we don't have any, we don't have any information about, so we just leave those blank. And now set that aside. Let's go back to our model. And now let's add the constraints. So I'm going to make those all read A once again. And now let's go back to that same estimate summary. It is reliably converged. So now you would expect, because we have constrained all three paths to be the same, in essence, it has made it so that we are only estimating one path. So it's one path 3 times. So it only has to do one estimate for all of these. And so we, instead of estimating 3 things, are estimating 1 thing. And so we would expect the change in the degrees of freedom to go from 3 up to 5. And this is always a good practice to get into, is to essentially see what would you expect and to make sure it lines up. And in fact, we do see that there are 5 degrees of freedom in this model. We go back to the chi-square here, 83.724. The change is just one minus the other, 3.602. And so, is that a significant change for 2 degrees of freedom? And I pre-populated this P calculator. You can look it up in a table. You can use a calculator like this, but you can see that in fact that is not a significant change. And so these paths can be constrained to be the same, and that is a reasonable assumption to make. Now that's really just the very first step in making one of these transactional models. And what we need to do now is to have a second set of variables. And I'm going to use, for no particular reason, these math scores. And once again, I'm going to add the stability paths. I need to free them. And now these I'm going to add constraints without actually testing it for the sake of time. Oh, I'm going to standardize them too. So I'm just going to label all of these B. So do remember that anything with the same name is estimated to be the same, and so you want to be careful working across your model that you're not accidentally giving 2 paths the same name that you don't mean to. Now we could do something similar with the errors and essentially assume that the error variance does not change over time. You could do the same thing for these errors. If you do that, do not include this first set, because those are not error variances, those are just variances. These are exogenous variables. But for the sake of time, I'm just going to move on from here, which is reasonable. And right now, if we looked at this output, the chi-square value, would just be the sum of these 2 models. You can see that these are completely independent models that it's running. So because we're running it all together, the chi-square would just be this model plus this model. We haven't done anything to stitch these models together yet. So let's do that. The first thing that we're going to do is we're going to add some, these would be correlations because we've standardized these variables. So let's add some correlations, and we need to free each of these. I'm actually going to pull this one over here. All I did is I clicked on it until I had those show up, and I can kind of move those around until it looks the way that I want. But I am doing that for a particular reason, because this correlation is a different correlation. Notice it is the correlation between two exogenous variables. Whereas these correlations, even though they basically look the same, are actually quite different. These correlations are the correlations between the error variances. And so I would like to constrain these, but I can only constrain the ones between all the endogenous variables. So you can see that they start out quite highly correlated, but these correlations are essentially quite low. And I see these 3 stars here. That's something that Onyx does that can catch you off guard. But anytime you see those 3 stars, what you want to do is go to Estimation and Show Best ML Estimate. In essence, what those 3 stars mean, and I can show you in the output. Is that the estimates that you're seeing here is a local optimum, and better estimates exist. And so we want to see those better estimates. You always want the best ones. And so what we will do is go to Estimation, Show Best ML Estimate, Maximum Likelihood Estimate. And you can see that our values changed in here, but this is the best fitting model, the best fitting iteration, if you will. So if we look at this output, you can see that our chi-square value is lower than what it was before, and that's because we've started to account for some of these correlations. This model winds up being our baseline for comparison. And so I would like to start to keep track of some of the statistics that it's telling us. And in fact, it's those same statistics that we were tracking before, the chi-square and the degrees of freedom. Now, hopefully it doesn't reveal too much, but I've already started populating this table. We have, what we are looking at is a correlations only table, or model, and we want to put into our table the chi-square and the restricted degrees of freedom. So the chi-square, 57, 0.189, and the degrees of freedom is 24. Great. Now things are going to get a little bit more interesting, because this is where we start to see is grade 2 language a leading indicator of grade 3 math. But it's actually all of these at the same time. Are these 3 leading indicators of these 3? And then we're gonna test the opposite. Is earlier math associated with later reading? Now, just for simplicity here, what I'm going to do is I'm going to clone this model. And we do that by going to Edit and Clone Model. And that just gives us something easy to work with here. And so now I can make changes to this one while leaving this one intact. And So the changes that I want to make is I want to add some paths. I'm going to connect earlier language to later math. We add the paths. You can select multiple at a time by holding down Shift. You right-click, free parameter. And then you can actually do the same thing to rename them all at the same time. And I always use a convention. This is just for me, there's nothing special about this, but I always call that path L1. So you can see that L1 is giving us an estimate there of 0.24. We can look, well, let's see. Let's show estimate summary. I'll bring this one over here. I will not bring this one over here. I'm just going to make it right here. And so L1 is here, and the estimate is substantially more than twice the standard error, so that is a significant path. But that's actually not how we determine whether this is an appropriate thing to do with our model. Instead, what we do is we pull up this little chart, and we're going to track the chi-square values here. Now, we have, in essence, only added one path. Even though we drew it 3 times, we constrained it to always be estimating the same value. And so what that means is that we would expect that we have used 1 degree of freedom. We would expect 23 degrees of freedom in our output. And in fact, that is what we see, so that's good. We did not make a mistake. And the value here is 196.218. The chi-square, or the change in chi-square, is going to be minus that. The delta degree of freedom is 1. And this is a very significant change. Okay, so we know, based on this model, that this L1 model is a better fitting model than this correlations only model. Okay. Now what we can do is I'm going to clone this model again. And we're actually going to test paths going the other direction. Same steps here. And I always call this path L2, just for my own convention. And let's look at the output. Again, relative to the unconditional model, it's just a 1 degree of freedom change. So we would expect this model to also have 23 degrees of freedom, which it does. And then, oh, actually it says this is the best found, but it's still improving. Technically, we should not move on until it has said, until it says that there it is, it's reliably converged. So we go to 192.349. The chi-square change is the correlations only minus this value. And again, we have 1 degree of freedom. So these significance values tell us that both this model or this model fit better than the original. But of course, a fourth model exists, and that model tells us it's a bidirectional model. It includes both L1 and L2. So what I'm going to do is I'm going to clone the L1 model, and I'm going to add in the L2 paths. Have to be a little bit more specific here. L2. You do need to be careful, of course, that you're only selecting the paths that you need to be selecting, and you're not renaming things that you don't want to be renaming. Okay, so something that can be helpful is to move these parameter estimates so that they're easily readable. Okay, so you can see that this model is a bidirectional model. It's testing whether earlier math is associated with later later language, and if earlier language is associated with later math at the same time. Now we, of course, can't say this is a causal sort of thing, but we can interpret it as a leading indicator in those earlier and later associations. So let's see what this output is telling us. Now, this estimate is still improving, and again, we should wait until it says it is reliably converged. And there it is. And so the bidirectional model, the degrees of freedom, we've added in each of these, L1 and L2. So I would expect that we have 22 degrees of freedom remaining, and that is what we see here. So it's always a nice check on yourself. The chi-square value is 164.561. Now this is actually an important decision that you have to make here. The delta chi-square is relative to something, and for both of these unidirectional models, the comparison was this original correlations only one. However, we don't want to know if the bidirectional is a better fit than the correlations only one, because it could be, for example, 191.3. And so it might be better than the correlations only one, but we don't know if it's better than one of these unidirectional ones. And so what you actually want to do is to compare this bidirectional model to the best fitting unidirectional model, and the best fitting for the chi-square here is a lower value. So we're going to take the lowest value that we see here. We'll take away this one. That is a 1 degree of freedom change. We've gone from 23 to 22. And you can see that the bidirectional model is, in fact, the best fitting model. It's better than each of the unidirectional models, and each of the unidirectional models was better than the correlations only one. Now, that walks you through the process for making a transactional model. There is a shortcut I'd like to show you, though. And what you can do is you can iconify each of these models. So I left these here for a reason, and what you do is you double click, and it makes it little like that. And I'm just going to leave them where they are. And then, just like you can draw paths between variables in a model, you can actually connect these by right-click dragging. And this isn't like a regression path or anything, but what it's doing is it's actually performing that chi-square test that we saw here. And so when you've got this, you should be able to hover over it, right? And it's a 1 degree of freedom. It's using -2 log likelihood values, which is related to the chi-square. And you can see that it's saying they are, so it's saying 60.971 970, very close. And so that difference is 60.97, p-value of 0.000. And so this is a way to do the same thing that you were doing here. Now, ultimately, you're going to need to report this, and this kind of table is a good way to report it. But in terms of just your own analysis workflow, you can just add these in and conduct your test that way. That way you know as you go what your results are without tracking everything in the table. I think that's a nice little shortcut. So there we are. This is a transactional model.